Introduction, Work Management. Work management is about making sure that all maintenance and reliability work is done in a structured, efficient, and coordinated way. It starts with recognizing the need for work and continues through to execution and follow-up. The goal is to ensure every job, whether it's a repair, inspection, or improvement, is properly handled using available resources like technicians, spare parts, tools, documentation, and time. It ties together all aspects of maintenance: technical, like work orders and job plans; logistical, like spare parts; and human, like technician scheduling, into a unified process. Without good work management, organizations typically suffer from delays, confusion, wasted effort, and reactive firefighting. Identify, validate, and approve work intake. This part deals with how maintenance work gets started. It's not just about someone noticing a problem. There needs to be a process to capture, review, and approve it before it becomes a scheduled task. Here's how it works. Identify work. Any team member, operator, technician, engineer can request work based on observed issues or scheduled needs. Validate work. Not every request should become a job. Planners or supervisors must check if the issue is real, if it already has a work order, or if it's justified. Categorize work. Each request must be sorted into types: corrective, repairs, preventive, routine, upgrade, improvements. This ensures it follows the right planning and prioritization route. Approval process. Assign personnel, typically maintenance leaders or planners, formally approve the work for planning. If it doesn't meet criteria, it may be rejected, deferred, or redirected. Use of CMMS EAMs. A computerized system should log, track tasks, and standardize all work requests. This provides transparency and avoids duplication. Escalation and communication. If a request is urgent or high risk, it should follow a defined escalation path. The system should also communicate status updates: approved, in progress, completed, so all teams stay aligned. This process prevents chaos by ensuring only necessary and validated work enters the planning pipeline, which is critical for resource efficiency and uptime performance. Prioritize work. Prioritizing work ensures the most important tasks are addressed first. This means emergencies like safety threats or critical equipment failures are handled immediately, while less critical tasks are scheduled appropriately. The process should classify work as emergency, urgent, or routine based on factors like safety risk, impact on production, and asset criticality. A structured prioritization system such as RIME, Ranking Index for Maintenance Expenditures, uses numerical scoring to evaluate the urgency and importance of each work order. The process must be documented, auditable, and regularly reviewed for consistency. Personnel must be trained to apply the system correctly, so priorities are consistent across the organization. Plan work. Planning work means defining every detail required for safe and efficient execution before it gets to the technician. This includes the job scope, materials, tools, craft skills, permits, testing requirements, and step-by-step job sequence. Planners are responsible for assembling job packages, managing spare parts kits, and ensuring everything is staged and ready. Good planning relies on estimating guides, historical data, and job plan libraries. These libraries help repeat common tasks consistently. A dynamic library should be maintained, meaning plans are updated based on feedback and new best practices. Schedule work. Scheduling turns planned work into action. Schedules are based on ready backlog, labor availability, and material readiness. Schedules should be built at multiple levels: daily, weekly, and long-term, allowing flexibility and strategic alignment. Effective scheduling includes shutdown, turnaround coordination, matching craft skills to tasks, and managing work center capacity using CMMS or scheduling tools. Regular planning and scheduling meetings help align production and maintenance goals, preventing conflict over equipment access and labor resources. Execute work. Execution is where maintenance happens. Success depends on the efficient use of labor, materials, and tools. Teams must follow EHS procedures, including lockout, tagout, confined space, and other permit controls. Work execution should follow job plans supported by quality checks, QA/QC, and visual aids like equipment diagrams or photos. Tracking technician skill levels ensuring the right people are assigned, and assessing training effectiveness are key to strong execution. Document work. After work is done, capturing accurate information is essential. This includes failure modes, parts used, tools, labor hours, and as found, as left equipment conditions. This data feeds back into the CMMS, keeping the equipment history, bill of materials, failure codes, and spare parts up to date. Well-documented work history supports root cause analysis, budgeting, forecasting, and continuous improvement. Without this documentation, learning from past work and improving future performance becomes difficult. Analyze work and follow-up. After a job is completed, it's essential to compare what actually happened versus what was planned. This includes looking at time taken, cost, materials used, and other performance factors. Variances point to planning inaccuracies, skill mismatches, or unexpected complications. Work history and benchmarking data help identify improvement areas. Cost data reveals inefficiencies. Techniques like FMEA, failure modes and effects analysis, DAR, RCM, reliability-centered maintenance, and RFA, root cause failure analysis, are used to optimize tasks and reduce future failures. Metrics like MTTR, mean time to repair, and MTBF, mean time between failures, help quantify asset performance. The outcome of this analysis should feed back into job plan updates and improvements to preventive maintenance strategies. Measure work management performance. You can't improve what you don't measure. Key performance indicators, KPIs, help track how effective and efficient your work management process is. Examples include schedule compliance, how much of the planned work got done on time; rework rate, how often work has to be redone; wrench time, the percentage of time technicians actually spend working; backlog, how much work is waiting; planned versus unplanned work ratio, a higher percentage of planned work means better control. Use CMS dashboards, reports, and regular reviews to monitor performance. Conduct gap analyses to find weaknesses, and drive continuous improvement through targeted action plans. Plan and execute projects. Work management includes not just routine maintenance, but also one-time or large-scale projects like equipment installs or system upgrades. These require formal project management principles from start to finish. Define project scope, roles, and objectives. Estimate lifecycle costs, not just upfront expenses. Use scheduling tools like CPM, Critical Path Method, and PERT, Program Evaluation Review Technique. Track progress, manage risks, and monitor cost and schedule performance. Execution tools include MS Project, Primavera, or other cost control systems. These projects should be tracked and closed with lessons learned and documentation, just like routine maintenance work. Use information technologies effectively. Modern maintenance depends on integrating various information systems to streamline operations and improve decision-making. Key tools include CMMS, Computerized Maintenance Management System, central for work orders, history, schedules, failure codes, spare parts, and KPIs. SCADA, Supervisory Control and Data Acquisition, monitors real-time equipment conditions, alarms, and trends. EAMS, Enterprise Asset Management System, broader than CMMS, managing full asset lifecycle. CAD, Computer-Aided Design, provides drawings and schematics to support maintenance planning. And HMI, Human-Machine Interface, connects operators and technicians with real-time process control data. These systems should be integrated to support seamless planning, scheduling, inventory control, failure tracking, and calibration management. When data flows across systems without duplication or gaps, maintenance becomes more proactive, accurate, and efficient. Manage resources and materials. Managing MRO, maintenance, repair, and operations inventory is vital for ensuring maintenance teams have the right parts in the right place at the right time, without tying up excess capital. This includes controlling stock levels based on asset needs and usage history, forecasting demand to avoid stockouts or overstock, monitoring shelf life for parts that degrade over time, e.g., lubricants, belts, kitting parts for specific jobs to reduce search and wait time. Tools and techniques used include ABC analysis, categorizing items based on usage value to focus on critical spares, EOQ, economic order quantity, determining the optimal order size to minimize holding and ordering costs. Lead time analysis, understanding how long it takes to receive parts once ordered. Procurement coordination, working with purchasing to align inventory with job plans. Contractor and vendor management, monitoring performance, availability, cost, and delivery reliability. Efficient resource and material management reduces downtime, improves wrench time, and supports smoother work execution.